Hi students, once again I welcome you all to my channel Abrar sir classes. ಇವತ್ತು ನಾವು EMI chapter ಇನ self induction topic ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣಪ್ಪ. First we will learn what is meant by self induction. Okay. What is meant by self induction? Okay. The production of induced EMF in a coil due to the change of current in the same coil. Okay, whenever the word self induction comes, we refer to the same coil is called self induction. What does it mean? The production of induced EMF in a coil due to the change of current in the same coil is called self induction. Okay, we'll read further. Consider an isolated coil or circuit in which there is a current I. Okay, current is increasing here. The current produces a magnetic flux linked with the coil that we know. Okay, the magnetic flux linked with the coil can be changed by varying the current in the coil itself. Example, by breaking and closing the circuit. Okay, we have to refer figure 1. If I refer figure 1, okay, here you can see the key. Key, it is pressed. Key pressed ಮಾಡಿದಾಗ the circuit will be closed. The current will be increasing. Now if I release this key, ಇದು key open ಮಾಡಿದಾಗ, okay, now the current will be decreasing here. Now here what it is saying in this paragraph, in this theory, it is if I is increasing, what happens to the induced EMF which opposes the very cause of it? Okay, E induced. Okay, I increasing. Now as soon as I decreases, okay, it will favor this E induced will be in the same direction. It is like this upper. Okay, let us consider a coil. Okay, if I is what? I is increasing at that point. I is increasing. Here I induced will be in the opposite direction. I induced will be in the opposite direction. I induced. ಇದು ನೆನಪಾಟ್ಕೊಳ್ಳಿ. Okay, same as your E induced. Okay, now let us say if a coil is there or circuit is there, if I is decreasing, okay, this concept will help you to solve the problem. I decreasing andre I induced will be in the same direction. I induced will be in the same direction. It's an effort. I increasing, I induced will be in the opposite direction. I decreasing, I induced will be in the same direction. Okay, understood? Hope you understood. If key is pressed, I increases. If key is released, I decreases. Now, with this concept, we will try to learn the solving of problems. The figure shows an EMF EL induced in a coil. Okay, which of the following can describe the current through the coil? I have given how many options? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 options have been. 2 extra I have given. Okay, 2 extra I have given. That will be no problem. 2 extra options to make you learn. Okay. Here what is happening? This is a coil. Okay, the coil is right body. Okay, E induced. Okay, E induced is like this. Okay, if E is induced like this, what should be the direction of current here? Either if I is what? Decreasing in the same. Okay, I have just written here. Okay, in the same way. Okay, this one I induced, I decreasing. One option is possible, and one more option is E induced ittaga. Okay, or I induced ittaga. Okay, This will be what? In the opposite direction. I is what? Increasing. I is increasing. Correct, because it opposes increasing. How many options are possible? C. The current is going here. I decreasing. It is I is decreasing andre decreasing and ಇದು right word left word decreasing and right word. Okay, very good. ಇಲ್ಲಿ second option in I is increasing and left word. Both the cases are possible, either this or this one. Increasing and left word. Hope you understood. Okay, hope you. How many options? Two options are correct here. Okay, two extra options, but okay, multiple options are there. Decreasing and right word. Decreasing and right word is also possible, and increasing and left word, because it is going left side. It's going to left side. Increasing and both the cases are possible. Hope you understood this one. Let us do the next one. What it is saying? It is saying a circular coil of radius, a circular coil of radius ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ 5 centimeter ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, convert this into meters. 5 into 10 to the minus 2. Okay, meter has how many turns? Number of turns are 500. Okay, 500 turns. Okay, bye. The approximate value of the coefficient of self induction. Okay, what is the formula for coefficient of self induction? Coefficient of self induction. You have to remember the formula. Coefficient of self induction for a circular coil is given by L is equal to mu naught into N square into pi R by 2. This you have to remember. If you don't remember the formula, we cannot do anything. Just substitution. Now substitution. L is equal to mu naught in the rest of 4 pi into 10 to the power of minus 7. Okay, into N and the rest to 500 into 500. Okay, 2 times we'll write 500 into 500. Okay, into pi into R and the rest to they have given 5 into 10 to the power of minus 2. Okay, divided by 2. Divided by 2. Understood? 2. Let's cancel. 2 pi ಆಗುತ್ತೆ. Okay, L is equal to 2 pi into pi is 2 pi r square ಆಗುತ್ತಪ್ಪ. Right, 2 pi r square ಆಗುತ್ತೆ. Right, into 2 pi into pi 2 pi square ಆಗುತ್ತೆ. Okay, into 500. 5 into 5 25. 125 ಆಗುತ್ತೆ. 125 into okay 10 to the power of 4 ಆಗುತ್ತೆ. ಇದು 4 minus 7 minus 3 and this is minus 5. Understood? Understood? 2 pi into pi ಅಂದರೆ 2 pi square ಆಗುತ್ತೆ. Okay, into 5 into 5 25. 25 into 5 is 125. 10 to the power of 4 minus 7 minus 3 minus 2 is minus 5. Pi square ಅಂದರೆ ಎಷ್ಟಪ್ಪ? Pi square ಅಂದರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ನಾನು 10 ತಗೊಂಡಿರ್ತೀನಿ. ಓಕೆ, L is equal to 2 into 10 into 125 into 10 to the power of minus 5. ಇದು ಎಷ್ಟಾಗುತ್ತಪ್ಪ ಇದು? ಓಕೆ, L will be equal to 250. Okay, 250 into 10 to the power of minus 4 and that one. Okay, that is equal to L is equal to 25 into 10 to the power of minus 3 ಆಗುತ್ತೆ. Right, that is equal to how much? 25 millihenry. 25 millihenry is the right answer. Hope you understood. Okay, be careful here. Okay, while calculating, take pi square is what? Pi square is 10 ಆಗುತ್ತೆ because 3.1 1 4 into 3.4 approximately I am writing what 10. Okay, that simplifies to 25 millihenry. Next problem. What it is saying, the coefficient of self inductance of a solenoid is Estapa L is equal to 0.18 millihenry. Okay, if a rod of soft iron of relative permeability mu r ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ 900 ಕೊಟ್ಟಿದ್ದಾರೆ. We are very clear that what is the formula for L, what is the formula for coefficient of self inductance. The formula for coefficient of self inductance is nothing but what? L is equal to mu naught into n into L is equal to mu naught into n into NA. ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳೋಣಪ್ಪ. ಓಕೆ, ಮುನ್ನ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. ಓಕೆ, ಮುನ್ನ MUNNA. ಓಕೆ, ಮುನ್ನ mu naught NNA. Okay, you can just remember. Now, if we insert magnetic material, if we insert magnetic material in core, then the formula will become same formula munna only. Okay, with extra term is what? Mu naught into mu r ಆಗ್ಬಿಡುತ್ತೆ NNA. Okay, that is only change. Okay, that is the only change. So what is the formula for L? If we insert magnetic material in core, L is equal to ಏನಾಗುತ್ತಪ್ಪ? mu naught into mu r into NNA ಆಗುತ್ತೆ. That is same as what? L is equal to mu r into what? Mu naught into n into NA. Okay, that is same as what? L is equal to mu r into LA. Okay, this L already they have given. So L is equal to mu r and ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರಪ್ಪ? 900 into how much is L? 0.18. Okay, into 10 to the power of minus 3. Right, that is approximately ಎಷ್ಟಾಗುತ್ತಪ್ಪ? How much is this 900 into 0.18 ಅಂದರೆ how much that is? 900 into 0.18 ಅಂದರೆ approximately that is 162 millihenry ಆಗುತ್ತೆ. Okay, 900 into 0.8 ಮಾಡಿದಾಗ you will get how much? 162. Okay, so 162 millihenry is the right answer. Hope you have understood this very clearly. Okay, kindly remember the formula. What is the formula for L? The formula for L is munna. Okay, I have written here. Okay, mu naught NNA, munna ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ. Okay, if we insert magnetic material in core, then same formula mu naught into mu r extra ಆಗುತ್ತೆ. Mu r is extra that you are supposed to multiply. That is the relative permeability. Understood? Hope you understood this. Okay, for today this much only pa. Okay, hope you understood these problems. If you have liked this video, kindly like it, share it with your friends, subscribe for my channel, and ask doubts in the comment box. I wish you all the best. Thank you one and all.